Part B, extended response. Question 1. A mortar is fired across a field and has a parabolic path. The projectile reaches a maximum height of 25 meters and it travels a total of 100 meters horizontally. Find an equation for the path of the object, which will be in the form of y equals negative ax squared plus c. It's always easiest if you can draw a diagram. So in this particular case, I'm going to draw the diagram, which will give me something that looks roughly like this, with a height of 25, and because it travels 100 meters horizontally, that means that it must be 50 or negative 50 here and 50 here. It is symmetric about the y-axis. This means that I have points that I can use. I have a point, which is my y-axis intercept, at 0, 25, and I have 2 points, one at negative 50 and one at 50. So to find the equation, I can use these. Because I know that the y-axis intercept is 25, I can just read off what c must be. So c is going to be 25. Leaving me with a general equation of y equals negative ax squared plus 25. Using the point 50, 0, substitute in 0 for y, 50 for x, and then simplify, giving me 25 equal to a bracket 2500, or a equals to 1 on 100. Substituting these back into my equation to give y equals 1 on 100, which is negative x squared plus 25. I get 1 mark for identifying my c value, 1 mark for calculating a, and 1 mark for answering the question, i.e. finding the equation. Part B. Create a graph showing the path of the projectile, labeling the graph with the quadratic function, height of the projectile, and distance travelled. We've already done a sketch of this, so we're doing this sketch on a proper graph. We have negative 50 meters, 50 meters, and 25 meters, labeling it with the quadratic function, and then we also need the height of the projectile and the distance travelled. So it's not enough just to put our coordinate points down or label our axes. You do need to write the 100 meters and then the 25 meters as the distances travelled. 3 marks, you'll have 1 mark for the shape of the graph, 1 mark for the domain. By the domain, what I'm referring to is the fact that our graph doesn't go below the x-axis. We stop here and we stop here. Your projectile cannot fall below what is seen as ground level or the x-axis. So you can't go any lower than this. The last mark is given for your labeling. Question 2. A rectangular garden measuring 12 meters by 16 meters is to have a pedestrian pathway of width x installed all around it, increasing the total area by 285 square meters. Part A. Draw a picture representing the given information. Well, it's a rectangular garden with a path around it. We know that the width of the path is x and that the garden is 12 by 16. The drawing is worth 1 mark. Labeling that drawing is worth 1 mark. Part B. Find an equation in the form of ax squared plus bx plus c equal to 0 to find the width of the path. Hint: the area of a rectangle is length times width. If we know that the area is length times width, and that the area is 285 meters squared, then we can take the length, i.e. 16, plus 2 lots of x, and 12 plus 2 lots of x, and get out an equation. So I have 12 plus 2x times 16 plus 2x. I'm going to expand this to give 285 equal to 192 plus 24x plus 32x plus 4x squared. Rearranging this, 0 is equal to 4x squared plus 56x minus 93. This is my end answer in the form of ax squared plus bx plus c equal to 0. Part C says to find the width of the path using the equation that we just found in Part B. In order to do this, you are looking to solve for x. For this particular question, I'm going to use the quadratic formula, substituting in a, b, and c, and then simplifying that equation. I will get negative 56 plus or minus the square root of 3,136 plus 1,488 divided by 8. Again, simplifying even further to get negative 56 plus or minus 4,624, or square root of, divided by 8. The square root of 4,624 is 68, which means my solution is x equal to 3 on 2 or negative 31 on 2. Now the length, i.e. x, which is the width of the path, cannot be negative. So we remove one of our answers, meaning that the width of the path must be 1.5 meters. Marks will be awarded for recognizing that you need to use length times width for completing your working, for getting an answer, and again, marks will be awarded for your method, for your working, again for your method of removing that negative x value, and for your answer. Question 3. In a small country town, the level of floodwaters, h, in meters, is described by the equation h of t equal to negative t squared plus 4t, where t represents time in hours after 12 noon on Wednesday. Part A. It was decided to evacuate the nearby houses when the floodwaters initially reached 3 meters. At what time did the evacuation occur? So we're looking for when h of t is equal to 3. So 3 equals negative t squared plus 4t. Move that across so we've got it equal to 0 and factorize it. When we factorize it, we'll get t minus 3 and t minus 1. That is by recognition. And then applying the null factor gives us t equals to 3 or t equals to 1. Note that the question says when it initially reaches 3 meters. So the first time where this occurs. Well, the initial time is at t equals 1. So after 1 hour, the floodwaters will have reached 3 meters and evacuation will occur. Note that we start at 12 noon and we're asked after when, not after how long, but when, which means we're 1 hour after 12 noon or we're at 1 p.m. That's our end answer. We'll get 1 mark for the method, 1 mark for the method for factorizing, and then 1 mark for giving a correct, i.e. 1 p.m. solution. The last part of this asks you to graph the function h of t. For some reason this hasn't shown up in my copies, so we will just do this like this. So part B, graph the function h of t. Now h of t when factorized is t bracket or negative t bracket t minus 4. So we have an x-axis intercepts at 0 and at 4. And if we look at halfway between 0 and 4, i.e. the x value of our turning point, we substitute that in for t and we'll get negative 2 squared plus 4 times 2, Simplifying that down, we get 4. So we have a turning point at 4, or 2, 4. We also have 2 other points. These are the points where our floodwaters reach 3 meters high, and we calculated that to occur at the point 1, 3 and at the point 3, 3. Label your axes as H of T and T. You'll get 1 mark for the shape. Again, 1 mark for the domain, because you can't have floodwaters that are less than 0. And lastly, 1 point for correctly labeling your equation. And that is complete.